let's finish up our notes on density. So they're out, ready to roll. So we've talked about now length, area, volume, mass, and our last topic of density kind of pulls together what we've been talking about. And you guys, as we talked about in our discussion for the question today, you have a pretty good sense of what density is. And so let's just kind of go over some of our definitions we're going to use. So density is the amount of matter packed into a given space. The more matter you have in a given space, the greater the density. It's a measurement of how compact the molecules are. So, if I took this bar of valuable pure gold and I were to cut it in half, what would the density of one of those pieces be? How would it compare? Tyler?
It would be half as much.
Agreed? I hear nose. Why nose? I cut it in half. Big shot?
The density of the same.
How? Cutting it in half.
Because it's still the same material.
Still the same material. But I'm cutting it in half. How is the density going to stay the same? Does that make sense, Alice?
Because the molecules on both pieces are still the same as what it was.
Yeah, by cutting this in half, am I changing the arrangement of the molecules?
No.
No, they still have the same compactness. What two factors do you think, how are we going to determine the density of substance? We need two things. We need to know two things about it. If you think about what we said density is, you probably can arrive at it before I tell you. Sean?
Its weight and its volume?
We need its mass and its volume. If I cut this in half, what am I doing to its volume?
Cutting it in half.
But
Dividing it.
what am I doing to its mass?
Taking away half of it.
So the mass would be 1/2.
Yeah.
Density is a ratio of mass to volume. And so when I cut this, if I cut it in half, yes, the volume is going to be less, but so is the mass by equal amounts. So the density of a given pure substance is a constant. At a given temperature, it doesn't change. A tiny speck of this gold has the same density as this block, which has the same density as this cube of gold. They all have the same density if they're pure gold, and if they're all at the same temperature. We had back here a bar of aluminum that you guys were measuring in the mass lab. The density of aluminum is 2.7 grams per cubic centimeter. Whether it's this chunk, a giant sheet of aluminum, a thin sheet of aluminum foil, all aluminum that is pure has a density of 2.7 grams per cubic centimeter. We actually have a chart that we will use sometimes, and I'm going to give it to you now. It lists the density of common materials. And sometimes you'll be asked to identify a material based on its density. What we call that as density is an identifying property. It can help us determine what an unknown substance is made of. Density also has to do with buoyancy. Does anyone know what that word means? Buoyancy? Not like buoyancy. Buoyancy. What is buoyancy? Huh?
Buoyancy is like how you stay afloat in some sort of liquid. So
Yeah, how things float. How is that related to density? How is density related to buoyancy or floating? Ali?
That means it's not as dense, so it doesn't float out.
So what are you saying? What will float in what?
Less, the greater the space between atoms,
Okay.
the easier it is to float up.
Okay, yes. So a less dense object, or liquid or gas, will float in a more dense liquid or gas. Now, it doesn't work for solids, right? Like this cube of gold, okay? This block of plastic is not going to float on a cube of gold. If we're talking about liquids and gases, solids, liquids, or gases of a lower density will float in a liquid or gas of a higher density. That's why a balloon that you blow up with your breath, does it float?
Yes. No.
Does?
No, with your breath.
No. Okay. If you look at the chart I just handed you, who can explain to me why does a helium balloon float, but not a balloon that you blow up by breathing into? Explain using the information I just gave you. Sean?
The carbon dioxide that comes out of the mouth is more dense than the oxygen in the air and more dense than as fuel. But helium, which is less dense than oxygen and so on, still float.
Very close, but we got to make a few adjustments there. First, what is the air surrounding us? Yeah? Should I light a match in this room? If there's air in this room or oxygen, what would happen if I lit a match? It would explode. So the air around us is not pure oxygen. It's actually a mixture of different gases. It's actually mostly nitrogen. Most of it's nitrogen. 78% of our air in this room is nitrogen. About 21% oxygen, and then other gases are mixed in, smaller amounts of gases. So, but you do have on your list, even though it's not a pure substance, air's density is listed in the average density of air. What about when we exhale? What are we exhaling?
Carbon dioxide.
All carbon dioxide? Most of what we exhale is nitrogen. Because just like we inhale the air and it's 78% nitrogen, when we exhale, also 78% nitrogen. Is there any oxygen in the air we exhale? Yeah, there is, a significant amount. You could rebreathe the air that you exhale a couple times. Still has oxygen in it. Our lungs don't absorb every molecule of oxygen when we breathe in. And then there's carbon dioxide. So the air we blow up, when we blow up a balloon with our breath, it's a mixture of gases, nitrogen, oxygen, and then a significant portion of carbon dioxide. And that makes it more dense than the air around us, which means that balloon sinks. When we fill up a balloon with helium, what's the density of helium? Give me an actual number. See it? Yes, 0.000178 grams per cubic centimeter. Okay. What kind of balloon would float even better than a helium balloon? Lily? Yes. Has anyone ever made hydrogen balloons? Never really have. Can anyone name a specific large balloon of hydrogen that actually carried people inside of it? Oh, there's a type of airship. What? No? Had a specific name, Nate, you know? A type of blimp filled with hydrogen that burst into flames and burned?
Zeppelin?
No, it was a type of Zeppelin. It was a Hindenburg.
Hey, you didn't call on me.
I tried 4 or 5 people. Sorry, I can't call on every single person, Colin. Colin knew the answer, everybody. Just so you know, Colin knew
Yeah,
the
all
answer.
right, there we go.
All right?
Thank you. That's all I want.
All right, yep, recognition. So, third point about density. When we heat up an object, do you know what happens when you heat up a metal to its properties? Obviously, it's hot. Other than that, Edis? It expands. Metals expand when heated. Substances in general expand when heated. And so does the mass change? If I heat up this bar of aluminum, am I changing its mass? No. But if its volume is increasing, what do you think happens to its density? I hear like miscellaneous things. Ella? It decreases because the molecules are not so compact. They're spreading out when I heat it up. This is the principle behind a hot air balloon. As you heat the air in a hot air balloon, what happens to it? It expands. It becomes less dense than the air around it, and less dense gases will float. And that's how a hot air balloon works. All right. So, when we are calculating density of objects, as we will be next week, really density is a calculation. It's not really something you measure directly, as in mass or volume. You guys already told me what 2 pieces of information you need. So let's just kind of review this before we start to talk about it in more detail. So volume is, what is our definition of volume? Volume is, sit up.
The length of the height of an object.
If it's a rectangular solid, but if it's not, Ashley?
Space.
Yeah, the amount of space that the object takes up. What about mass? What's our definition that we are using for mass? Mass is the amount of matter. So the formulas that we use in calculating volume equals length times width times height, or volume equals pi times radius squared times height. We don't have a formula to calculate mass. We measure mass using a balance or triple beam balance or electronic balance. What about our units? For volume, what are our possible units? Ali?
Centimeters, millimeters, centimeters cubed.
Yes? No. Centimeters cubed, or what did we use? Millicubes? Milliliters. We have other, we could use liters or other. Units of mass. Raise your hand. See ya? Grams. What else? Ella? That's really more of a weight or force. Kilograms, grams, milligrams. What equipment do we need to measure volume? You were just doing this yesterday. Some of you just last period. Say that? For volume? A ruler or, well, you could use a calculator. Graduated cylinder. How about mass? Triple beam balance? Or an electronic scale. Okay, density then. So density we said is how much matter there is squeezed into a given space. Could anyone guess how to calculate it? Think about what it is, and maybe you can arrive at how we would calculate density. Colin?
D equals M times V.
You're close, but not quite. Remember we said this is a ratio? What indicates a ratio in math? So we're looking at the ratio of what to what? We're thinking about density, it's the ratio of,
You said this earlier, I can't remember which
Volume
one it was.
divided by half. Half.
is it? It's volume and mass, but which is on top?
Oh, mass is on top of volume.
Yep, it's the ratio of the mass to the volume. The more mass we have, the greater the density. So what are the units that we might use? I tell you, but you could probably figure it out. Ali?
Use grams.
No, grams are for mass. What up?
Hogshead.
No, you're not going to be using hogshead.
That's part of the customary system.
We don't even know what that is. What is the customary system?
Those crazy
Never heard of it.
people across the pond.
All right, Ella? Very close. What unit would we have if we're figuring this out? What unit's up here?
Grams.
Grams. What unit's down here?
Centimeters. Cubes.
Centimeters cubed. So what we do with our numbers, we do with our units. It's grams per cubic centimeter, or grams per milliliter. Which should make sense. What we're saying with our units in density is every cubic centimeter of gold has a mass of X. Okay. If we double the volume, we double the mass. So it's a ratio of mass to volume. The equipment we use, we don't really use it. We calculate it. We have to measure the mass of the object, we measure the volume of the object, and then we calculate it using that formula. So our formula, D equals M over V, density equals mass divided by volume. It's just a ratio. And so this is why the volume doesn't matter. Because if you have more of this, you have more volume, but you have more mass. And so the ratio of mass to volume is unchanged. All right, let's read this over. Osmium
Yep.
is a hard metallic element. It's the densest substance on Earth. Okay? The close spacing of the osmium atoms gives it this very high density. A cubic centimeter of osmium contains more atoms than a cubic centimeter of gold or uranium. So, gold, as you know, because you were talking about Scrooge McDuck earlier, or I was used as money. Why was gold used as money frequently? You ever know the reason? Like gold coins were the currency of ancient Rome or other places. Okay, the density does help. Can you guess why? How is the density of gold? Why is that a help if you're trying to use it as a currency?
Because it's not huge to carry with you.
Okay, that's a good point. Yes?
Measure it exactly.
Okay, that's a good idea. Walker?
It's heavier.
It's heavier. So if somebody gives you coin of gold, and gold is a very high density, okay? Gold's density is 19.3 grams per cubic centimeter. And if somebody gives you just a gold-colored metal, you would certainly feel the difference in the weight between those two coins. Okay, so it's easy to identify. Gold is also fairly rare,
That's what I was.
but there's still enough of it that you could have lots of gold coins, so it's not so rare that you can't have a lot of it. So that's one of the reasons it was used. So let's look at this little problem here. A merchant was suspicious that the gold that he was being used to be paid was diluted with less valuable substances. So he computed its density by measuring its mass, dividing its volume, and then comparing that with the actual density of gold, 19.3 grams per cubic centimeter. So the gold nugget that was used to buy the suit had a mass of 47.9 grams. It had a volume of 3 cubic centimeters. Is this a gold nugget? Maybe. We can know for sure. Figure it out. Is this a gold nugget? And use those calculators that I know you're supposed to bring to class every day. John? Raise your hand when you arrive at an answer. So, is this gold, Edis?
No,
How do you know this?
because I divided
Okay. Who else has an answer can explain? Is this gold? You think it's gold, Walker?
No, because when I divided 47.9 by 3, I got 15.966.
So, no, it is not. When I take the mass of this gold nugget, which was 47.9 grams, divide it by the volume of this gold nugget, 3 cubic centimeters, I find it actually has a density of 15.97 grams per cubic centimeter, and that is not the density of gold. We know this is not gold. Whoa, whoa. All right.
You know what sulfur hexafluoride is?
No.
It's like opposite helium.
I mean opposite.
It's like it's not opposite helium, but it's more dense than air and
Oh.
helium. So like, you know how people do like the helium challenge where they breathe in
Oh.
it's just high?
Oh, I see, yeah.
YouTubers do that, and
Yeah.
their voice sounds like Darth Vader. It's really cool.
Probably not very healthy.
No, yeah, no, it's not. You have to like, it sits in your lungs, so you have to like cough it out
That
afterwards.
doesn't sound like a great
I
idea.
still would want to try it.
Anything for the views. All right.
You should do that one time.
I should. Yeah.
Wow.
Five
Let's talk
hundred.
about how unhealthy it is. Now you're saying I should do it.
500 subscriber giveaway.
Yeah.
Sulfur hexafluoride challenge.
This is me speaking directly to the American people.
All right. Let's do this. Calculate the density. So first, what's our formula for density? Remind me. You cannot go until you tell me the formula for density, Ali.
Density equals grams divided by
Mass divided by volume.
I was so close.
No, you were not that close, Ali. Hello?
Bob's your favorite.
Yep. Oh,
Sure.
Good. No, you guys all know it.
Oh, okay.
Ali.
He gave me
I'll say something worse.
He knows. All right. Don't forget your math is due on Tuesday.
I just need to do one more measurement. Why are they leaving?
You don't have any measurements up. You don't have time to do them. You're not going to have time to do them. All right, to calculate the density of this, let's figure it out. You have the dimensions of the cylinder. What? Go ahead, do this. Calculate the volume. Figure out the density. I have confidence you can do this before the bell rings.
Yay. Well,
I believe in you, students.
sorry.
You shouldn't.
You actually.
You shouldn't.
One's on this on my paper. This is
You can do it. Hey, we're whispering to ourselves. Is that part of the process?
it helps me.
We'll see. I will reveal the answer momentarily. You're going to be left in suspense. Are you right?
No.
Are you wrong?
Oh God.
That is- Oh, I see someone's doing a rent by hand. Why do we do my rent by hand?
They did not calculate.
Not smart.
Yeah.
On your quiz on density, if you do not bring a calculator, you do all of your math by hand. On a long quiz. Not fun.
Get this answer.
I got it. I don't think I can allow that.
Wait, I definitely got this. I'm about to get it in like 5 seconds. Wait, 4, 6. Well, you just farted it all.
You have to do the Oh.
What's happening here, Deja?
Oh God.
It looks like not that much.
Can we run to the nearest
I don't get
Nearest what?
tenth?
Yeah, sure. 10th is okay.
I did it. I think we need to switch.
All right.
That's the answer.
Are we ready for the big reveal?
I think we actually got it right. It's not me. I don't want to be
Big
wrong.
reveal?
I don't want to be wrong.
1, 2.
That's not what I was waiting for.
3.
Yes!
Yes.
We're smart.
Yes. Oh, I know what I did wrong.
How do you?
We got it right. Let's go, team.
Oh my God, I did the volume wrong.
Oh.
How do you do the volume?
I just realized that you should see that class if we were about to take a last one.
She's like, I thought it was the reflection of Mr. Duras, and I got confused because it's a lady.
What element is this?
Silver.
How do you know? How do you know it's silver, Walker? What? The density chart tells you. The density of silver is what?
10.2. The volume is the density.
All right. Don't forget to finish your lab this weekend, people. Have a good weekend.